Hello, hello, and welcome back to the Pendle Suite. You're in for a treat now. It's going to get very, very exciting indeed. It's a multi-speaker session. It features real-life radio hardware, all the elements, and I will, all the elements and all the ingredients for a very exciting talk. I'm sure that our first speaker will then introduce the subsequent speakers as they come up on stage. So initially, let's give a very, very big ComCon round of applause to Mr. James Bodie.
All right. We had to do that. I wanted to do the reprise, which says, "Dangerous, so dangerous, I want to do it again." So we've got a bit of a change of plan to what it said in the original schedule. But first of all, I think most of you know me, but if you don't know me, hello, I'm James. I'm CEO of Telet, platinum sponsor. And can I get this to go? Just a little bit of advertising. This is what we do. We're a mobile network operator. We're in MNO number 5 in the UK, the one that nobody's ever heard of. But we are a full operator member of the GSMA. We have Spectrum. We have interconnects, mobile core numbers, full shooting match. And what we do is we focus on provision of fixed wireless access, multi-operator neutral host, and private networks and applications. So basically, we will sell a mobile network to anybody who wants it, basically, and then plug it into other people. So that's who Telet are. Probably enough of that. And this is what we do with our projects. Yeah, we do all of that, so I don't want to bore you with that. On your schedule, it said that we were going to have the wonderful, dynamic Professor Suk-Chan Lee from Seoul University speaking to you about Open5GS. Sadly, he couldn't make it. Academic commitments meant that he had to cancel on us. So unfortunately, you're left with me. But we've kind of innovated a bit. I'm going to tell you a bit about Open5GS anyway, which is one of the most wonderful bits of open source software that we use extensively in Telet. So Open5GS, what is it? Well, it's all of this. It is an open source implementation of a 5G core. Any of you who know how complex a 5G core is will realize what a massive undertaking that is. A 5G core is incredibly complicated, and I'll show you how complicated it is in a moment. But what that enables people to do is to build their own 5G or 4G core, 4G network, and become a mobile network operator. That was never possible before. It is a real game changer in the mobile network space. And without Suk-Chan Lee leading this, we just wouldn't be here. It is a massive undertaking. He is a superstar of open source, and hopefully he will make it across here to Europe next year. So, yeah, implemented using that language. It's got a web UI, and it's supported by these people. You'll probably recognize tiny little Telet. Also, Nidan, you're there, another supporter, another fan of Open5GS. NG Voice, you'll probably recognize, good old Carsten Bock, and a couple of other bits and people on there as well. Yeah, quick word about what's so good about open source. In the past, we've used commercial cores to do these things. I personally have used a Nokia core in the past. One of the big problems with a full commercial core is your ability to change it, to make it do things that it was never intended to do. And my track record is one of a person who tends to kind of push the boundaries a bit. And I always want to do things with applications that they were never designed to do. So for me, open source is the obvious way to go. Mandatory, very complicated diagram. The purpose of this diagram is to give you an impression of how complicated 5G is. So Open5GS are the two grey boxes up at the top here, that bit and that bit. So this big box here is the control plane, the signaling, the bit that controls everything. And then this bit in that box is the user plane, where the media goes. But to make a 5G network, you need the other bits. And so down here, we have here a 4G or 5G NSA, non-standalone radio system. And I'll tell you what that is all about in a little bit. And over here, we've got a 5G standalone radio system. Later, we'll show you some 4G, 5G NSA, and 5G SA radios, because we've got a complete suite in our demo setup. The green lines here show the 4G signaling. The red lines here show the 5G signaling. Note that 4G and 5G use completely different signaling. Okay? Complicated, but that's the way it is. Also, note this tiny little box up here, which says IMS. That's the bit that allows you to do phone calls and SMS messages. Note that is not part of Open5GS. Yeah, this little bit over here is the messaging center, what used to be called an SMSC as well. They're not part of Open5GS. Whew, that is complicated, isn't it? There's a lot going on in Open5GS, but to summarize, it does 4G and 5G signaling and deals with the user plane as well. It's where the media goes. Okay, it is currently 3GPP release 17 compliant. So there's this standards organization called 3GPP. The name comes from, they're the organization who originally thought up the 3G specs, but they also thought up the 4G specs, and now they've done the 5G specs, and they're working on 6G, but they're still called 3GPP. Confusing, but that's where it is. So the first 5G bits and pieces came out in release 13, but actually became practicable in 2017 with release 15. So release 15 defined 5G NSA, and a little bit more about 5G NSA in a moment. Release 16 gave us the first standalone 5G new radio, and currently we are at release 17. With each release, you get extra functionality, extra bells and whistles. So that's where we are at the moment. And release 18 is due out about now. So, okay. So, but Open5GS is at release 17. Let's compare for a moment 5G NSA with 5G SA. So basically, 5G NSA is a 4G network, but with some 5G radios tacked on. Virtually all of the European 5G networks that are deployed today are 5G NSA. They're not really 5G. They're actually 4G networks with little bits of 5G radio. What that means is that they can go fast, and that's it. They don't do all the things that a 5G network can do. Yeah, so yeah, what does it say here? Yeah, it gets increased speed by stitching in additional waveforms, including 5G new radio. In fact, it's possible to run 5G with no 5G radio at all, which is interesting. The big advantage from an operator point of view is that you can use your existing 4G core. 5G standalone is full fat, the real deal 5G. So it has a much richer signaling scheme underneath it. So fully independent 5G infrastructure, and it offers all of the 5G capabilities. Lower latency, network slicing, more of that later. Network slicing is really, really, really important to us. And also the ability to stitch together multiple transports in one coherent network. So you can have bits of 5G radio, 4G, even Wi-Fi and IoT, but all controlled through the 5G control plane. Okay, it's incredibly powerful. So that's what the difference between 5G NSA, as used by all the other operators in UK, and 5G SA. There's only one MNO in UK that has a fully operational 5G core, and that's us. None of the others do. So there we are. A word about slicing. Slicing is the ability to give your applications, and it's applications that everybody's really interested in, the quality of service that they need to do what they need to do. And all the time, we're talking about trading off in 3 orthogonal axes. And these are bandwidth, power stroke range, because power and range are effectively the same thing, and latency. And if you increase one, it'll normally decreases the others or makes them worse. So everything is a trade-off. So in a busy railway station or an airport, you want masses of bandwidth, not a lot of range. Out in a rural environment, you want a lot more range to give you to cover the ground, but you're not so bothered with the bandwidth. And what 5G gives us is this ability to trade off in these orthogonal axes. There's actually a fourth axis as well, which is all about noise floors and modulation schemes and things like that, which affects the other 3. But for now, we'll just leave it at 3. That's complicated enough. To give you an idea of the sort of things that are going on in these application slices, this is an extract of some of the 5 QIs. And a 5 QI is the same thing in 4G as a QCI, quality control indicator. So you define in 5G what kind of service you want. So, and note, in 4G and 5G, the concept of voice calls really goes away. Instead, in 5G, you have a 5 QI1, which will give you a priority level of 20, a packet delay time maximum of that, error rate of that, and that's what you get every single time. But running alongside that, you have all these other applications, each with their own quality indicator. And kind of that's the way it works. Whew. Right, keep on pressing the button. So let's talk about the radio bit now. The radio bit, yeah, spectrum is really, really important. Without spectrum, your 4G and 5G system can't work. And not all spectrum is equal. Certain bits of spectrum are much more valuable than others. So as a starter for 10, the spectrum that you need has to be compatible with the devices that you've got in your hands and pockets, because if your phone can't work it, then that's no good. Different bands have different characteristics. So typically, lower frequencies are better for long distance use, but the lower bands tend to be narrower and therefore have less capacity. So because of that, for a high density demand situation, you will end up using higher frequencies. In rural dispersed scenarios, you'll have lower. Here in UK, we have two main routes to spectrum, mobile spectrum. One is called shared access, and the other is local access. Shared access, the UK regulator, Ofcom, have given us 4 bands that we can bid for. And you can get a license to operate mobile infrastructure relatively quickly, which is great. What is not so great is that the chunks of spectrum they've given us are not so super. One band stands out as being particularly useful, and that's N77. That's 3.8 to 4.2 gigahertz. It's wide. You can run 100 megahertz wide, and you can go quite fast on that. We have a demonstration running outside of a radio which delivers around 1.3 gigabit per second to a standard mobile phone. So if you haven't seen that, do come and see it. So that's shared access, but local access is somewhat different. Local access is where we can get a secondary license on any of the primary mobile bands on the provision that the primary license holder is not using it. This is particularly useful in mobile hotspots where there's no coverage, because by definition, in a mobile hotspot, none of the spectrum is being used. So it's all available. The drawback at the moment is the time that's taken to get a license, because at the moment in UK, the application has to go through the mobile network operators. And as you can imagine, they're not wildly enthusiastic about other people using their what they think is their spectrum. So they slow things down. The end result is the flash to bang time is about 6 to 12 months to get a license. However, we have a cunning plan to change that. And Team Telet are demonstrating, or just about to demonstrate, a dynamic spectrum access process, whereby the radio will do a quick look at what spectrum is in use, and then talk to a spectrum access server and get a lease back. The MNOs will not be included in the decision cycle. The end result is that 6 to 12 month delay goes down to less than 2 minutes. So all of a sudden, local access licensing becomes hugely, what's the word I'm looking for? Practical, yeah, commercially viable. And you will be able to get spectrum anywhere, but particularly in the places where no spectrum is being used. So that's DSA. Right, press the button. How are we doing for time? Yeah, let's talk about competition. How robust is your waveform? A couple of years ago, I attended a demonstration where they were demonstrating what happens when you overlay a normal Wi-Fi signal with a mobile waveform, OFDM-based 4G, 5G waveform. And in a one-to-one contest, there is no contest at all. The mobile, the OFDM waveform, the 4G, 5G waveform, will win every single time. It's much more aggressive, much more robust, because it's designed to be that way. Wi-Fi is not really designed to be super robust. It's designed to give you maximum speed over a very short range. Where it is important is it's now possible to put 4G and 5G into license-free bands. So your iPhone or top-end Android is capable of running 4G or 5G in the 5 gig band. But which waveform wins? It's going to be the mobile signal, the 4G, 5G waveform every time. Another big problem we have to make everything work is sorting out the settlement, how you bill and charge for this. Those of you who know us will know that we've been demonstrating multi-operator neutral host for some years now. But even though we've been doing that, we still haven't totally sorted out the settlement. So if you turn up in places like the Chalk Valley, your phone will attach to our network with your AT&T or Vodafone or EE SIM, whatever. You'll get service. You'll be able to make calls, receive calls, send SMSs, but we don't get any money from it yet. That's a bit of a problem for me as CEO of Telet, because whilst it's great giving away service for free, I would really like to be paid for it. But we're inching our way closer to actually getting money out of it now, which is great. 5G billing and settlement is somewhat more complicated than the old GSMA tap record-based billing, which is being phased out. So BCE is the new form of billing, and rather than being billed just on megabits of data, SMS messages, and voice minutes, you're now going to be billed on amounts of data per QCI. And there's the ability there to change the cost of or the price of a QCI dynamically so that if demand goes up, the price goes up, which in itself is an interesting concept, but as you can see, it will lead to a much more complicated real-time billing mechanism. BC is mandated for use in any 5G network, and because the billing is complicated, there currently is no full 5G roaming yet. There's 5G NSA roaming, but that's really 4G roaming appearing. But at the moment, there is no interoperator 5G roaming because the billing and settlement is really complicated. Okay, something else we're working on at the moment. And for those of you who are app developers, hopefully this will be of interest to you. What we're very interested in doing is working with our friends out there to implement some form of kind of app store, but for applications that sit on the mobile core. And wonderfully, bizarrely, we have managed to build one of the first ones of those, and we're going to demonstrate it to you live, operating on that radio down there in a couple of minutes' time. So the reason we want to do this is because it's the requirement for apps that will drive the demand for the private radio access networks. So the more apps you have available, the more radio access networks will be able to sell. Well, that's the theory anyway. So, yeah, another little advert. We've got a whole load of these things here. This is a cable-free radio, exactly the same radios we've deployed in Liverpool, which you'll find out in a moment when Andrew gets up to speak, is still the largest private 5G SA network in Europe. It's in Liverpool, Andrew is going to tell you about that in a moment. But we've got a pile of these kind of semi-surplus at the moment. And so we're offering them to the community as kind of dev boxes. We've configured these ones as a complete 5G or 4G network in a box. They come in two bands. Band 3841, it's the same thing, and N77. The difference between the two is that you can run 4G on band 3841, but N77 is 5G only. So you can take your pick. We've got both flavors. We've dropped embedded Open5GS onto them, so everything you kind of need for a standalone 5G network is on there. These are UK designed and built, and they're exactly as deployed in Liverpool. And I think, yep, that's all I want to do. So I am now going to hand over to my brave colleague, Andrew Miles. As a quick introduction, Andrew is largely responsible for the success of Liverpool. He's worked extremely hard on that. Haven't you, Andrew?
It feels like it, yes, so thank you for that. So we've been to Blackpool, so now we're going to move a little bit south and west to Liverpool, to home of a couple of reasonably good soccer teams, I understand, host of the Eurovision Song Contest for Ukraine this year. It's regarded in the UK as one of our party capitals. It's home to a world-leading children's hospital, Hay, 2 universities. It's a fun place to be and work. So I'm the second person on that line, but the real reason putting up this slide is the team across the bottom who put together the network in Liverpool. It's quite a diverse team, bringing in the local council. The local council really are the people behind the initiative. So there's an amazing woman called Anne Williams, who's the Commissioner for Adult Social Care in Liverpool. And she had the vision of using wireless communications to help deliver social care in the community. Despite all of the things I've just been waxing lyrical about Liverpool, it also has one of the poorest regions in the country, so an area called Kensington and Fairfield. Nothing like Kensington in London. It's one of the country's most economically deprived areas. And that's where we focus this deployment of a 5G SA network to help deliver health and social care services in the community.
Next one.
So there's are you doing there?
Yeah,
moving on.
Just tell me when.
Okay, now's good.
Now?
Yep. Marvellous. So why would a local authority or public body want to operate their own network? You thought that the national operators could do that for them. Well, there's a few reasons. Where and sometimes sort of public provision doesn't do quite what you need it to do. So being agile, the idea that you can deliver service to anyone, anywhere in that area, if somebody has come to A&E and you probably don't need immediate attention, but they want to keep an eye on them, they say they live in Kensington and Fairfield at the moment, the hospital can give them a box and say, well, look, take this home with you. We know it will connect. It doesn't matter whether you subscribe to broadband at home or whether you're an EE customer. We can keep an eye on you while you're there. Cost, and it's more than cost. So it's about promoting innovation. So if you've got an application idea that could really help someone, and it's going to cost you per megabyte or per gigabyte, then that's a bit of a barrier. You're always going to be thinking, well, how do I make this economical? How do I make this careful with data? If the local authority own the network, that's fine. They can say, use as much data as you like because we're in control of the business model and the gigabyte charges that go with it. Service. If you're relying on a network for helping somebody take medication and that network fails, you really want to know now so that you can put someone in a car and they can go and help them take that medication. You don't it might be unhelpful to discover that in the morning where something bad might have happened. And that integration is something that's very difficult to do with conventional commodity providers. Assets. So this is part of now, this is relevant to Open5GS and open technology. If we can make what has historically been quite a closed community, the mobile community, the 3GPP community, relevant and accessible to other people, other methods of working, other security models, then the assets that local authorities, public assets, can be used much more efficiently. You can use the same people to do the installation, so the guy who changes the street lamps, the light bulbs in the street lamps in Liverpool, watched us, we did it together, install a base station on lamppost, no problem, I can do that, and away they go. And we don't need to turn up with 3 people and a laptop and a telecoms engineer. It's straightforward. And then openness. Any application that's in the public interest can be deployed on those networks if they're controlled and by public bodies. Okay. So very, very rapidly, so can anyone see a Scotty dog? A Scotty dog. Yeah, you got it. So that's Kensington and Fairfield. That's where our 5G base stations are. Open5GS is in a data center. That's Ames down here in the bottom right-hand corner of that diagram. That's got a 10 gigabit fiber network. It originally had analog over fiber, CCTV cameras connected to it, and now they're all digitized. So we've got a 10 gigabit at the moment backbone throughout Liverpool. From there, it goes to street lamps, and then a millimeter wave mesh network, and then that connects to small cells on those lampposts. A bit hard to see on any of these diagrams, and that provides the service. Next slide, please. So here we get to the point, the role of open technologies in Liverpool 5G. Those open technologies have allowed us to adapt 3GPP networking technology to existing partners' existing processes, and that's particularly been relevant in the data center, and it's built like a data center or an ISP model. And then we looked at how 3GPP worked and thought, actually, those interfaces are quite difficult. The accounting is different. The way security is handled is different. So we're not alone in tackling this problem. I guess our SIPGate friends have had to do the same thing, bringing an MVNO together with voice over IP. But that was quite an eye-opener, and meant that we had to get into the architecture of the network that we were deploying and make things look different and make things fit with the processes that were already there. And we've already talked about deployment, provisioning, and reuse of those existing processes and skills. But it also, in Liverpool, has fed academic engagement, so that network is available to the 2 universities who are both running postgraduate courses on the network. They can get in the radios, the software-defined radios, they can change things, they can experiment, they can measure. And there was one other thing on that slide.
Sorry, we're running out of time.
What was the other one?
We need to keep going.
Okay.
Keep going.
Yeah. Okay, so then in the technical detail, so some of the things I've talked about, so mapping subscriber identities, we brought that through into the existing processes. We adjusted the way accounting was done. Traffic segregation, there's a combination of health and social care users and education users on that network. Resilience, because we had to do the backhaul over a millimeter wave mesh network. Redundancy, the service-based architecture, 5GSA service-based architecture makes it much easier for us to distribute components around different sites in the network. Mapping 5G quality of service to DiffServ, and then metrology, so what are they called? Things, looking at the signaling, being able to forensically examine what was going on in that signaling, and the universities really helped us with that. So we've missed a crucial slide, which was all about the applications. But
where?
I don't know where that went. But if you want to know, yes, that's the one. So that's Anne Williams, top right there, with someone in one of the primary schools. So in Liverpool, 50% of primary school children don't have access to connectivity at home. and we were able to send them home with Chromebooks. And interestingly, we thought that their parents would help them use the Chromebooks. It wasn't that way around. It was the other way around. So we were also enabling families to be digitally connected and dealing with some of the digital divide. And then there were some other applications on there, which I'm sure you can use your imagination and see what's going on. So thank you very much. That's a bit about Liverpool.
Brilliant. Thank you, Andrew. And now, the bit that you've been waiting for, the never-seen-before dangerous demo. Introducing my good friend and colleague, Luca from SignalWire. Luca has had one of these network-in-a-box cells for, what, a couple of weeks?
Yeah, fully working for a couple of weeks.
Yeah, and so the objective there was to build an application that would run on the mobile core.
Correct, yes.
And the clever bit is that the bulk of this application is running on the edge. And when we say on the edge, it's actually running on the radio. So why do we want to do it? Well, you're going to tell us why, aren't you? So I shut up and sit down.
So when James offered to send me a radio, I was super excited. Like Christmas came a month ago in my town. And the idea was, so as my job at SignalWire as solutions architect, I'm always thinking about what can I do with things I have. There's wonderful technology being presented all around here. Some of that, all of that as practical applications. But my goal is always to build something that works, that's usable. So we set up with the idea of, 4G, 5G cells, first of all, have good processing power. I literally discovered that when I got the cell from James. It's a 4-core, 16 gigabytes, and it's got a good SSD on board too, and it's actually quite nice. So that got me thinking that moving services closer to people improves experience. We did some work last year with Verizon about deploying to their wavelength edge, and in some cases that was reducing latency times by 90%. That means it's 10 times faster. The response for the simple application that would just do ASR and respond back was so quick, it was actually jarring. We had to add a little bit of delay because it was the app would start speaking right after you'd stop speaking, which is quite impressive. The other thing is we have been talking to various customers and prospects about doing self-contained deployments for private networks. So this benefits a large private network. This is something like it's deployed in Liverpool, but it's something that we could also use in contained environments such as factories, airports, cruise ships. And it's an interesting ecosystem that can be built around the fact that these things are computers, pretty much. That's all there is to it. Like, that's where it starts. So what we currently did is I have quickly deployed it's a SignalWire FSC, it's sort of a version of FreeSwitch that we're running on the stripped-down version that we run for this experiment to the cell. And we're doing simple OTT SIP calls for the moment because we're still getting this. I'll get to what the end goal is in a minute, but for now we'll be doing an OTT simple interaction locally based on dial plan. But everything is running on the cell, meaning call setup is extremely fast. The first interactions are super quick. And then just pipe up to our newfangled AI engine in the cloud, which my gracious colleague Brian West set up with a demo that's a call into a venture capital office that's going to check out what their ideas look like. I'm just going to do a quick demo because we don't have much time, and I'd like to delve into some of the technical details and especially what the future looks like for this, because this is the start of the App Store concept. That's an operator-neutral App Store that could be deployed at the edge level, meaning edge meaning the radios, but also meaning the backhaul data centers, or meaning up in the cloud. So let's see if this works. Do we have audio?
Ruiz and Anderitz. I'm Elizabeth Simon, a venture investor from Silicon Valley. May I have your name, please?
My name is Luca.
Nice to meet you. Luca, how can I assist you today? Would you like to hear about my background and the firm?
I'm looking for information about a company.
I'm sorry, I didn't quite catch that. Could you please repeat your response?
I am looking for information about a company.
Certainly, Luca. I'd be happy to help you with that. Please provide me with the name of the company you would like information about, and I'll look it up for you right away.
I'm looking for information about signal wire.
Thank you for providing the company name, Signal Wire.
There's actually office noise in the background because Brian built it like
Signal
that.
Wire is an API and products platform that brings broadcast and enterprise-grade communications.
This is just a demo. It's being looked up through the Crunchbase API.
Now that we have
this
some
will really
information
tell
about
you
Signal
anything
Wire.
about any company. So the architecture here again is a FreeSwitch core running completely on the radio that's doing the initial dial-plan interaction locally and just batching up to the cloud for the audio. But the future is going to be much more interesting. We're working on a mini IMS core based probably in Camilio to do a full SIP intercept, meaning that any call done from the native dialer just feeds into a SIP connection of sorts. We're going to add ASR and TTS using a local BANFO model it's a very good model. They're both very good models. They're low resources, they're pretty fast, and they support a lot of languages. Plus, they allow you to make your IVR speak like Trump, which is always fun, unless you're American. The next step, which is the more involved, is I'm currently working on training a small LLM with local intent detection capabilities. This is sort of a side topic, so so the 20 seconds version is a cell can run a small LLM that's capable of doing task-style detection. So you can train it to find out what the user wants to do within a list of things. Like I want to be able to call my office or talk to sales. So effectively a supercharged IVR, a cell or a data center is currently not able to run an actual full OpenAI style engine or something like a 30 billion parameter engine. So we can put that up in the cloud using our existing SignalWire cloud infrastructure to be able to run more complicated interactions. The goal is to have something local that will run your first pass directly on the cell, which will be super fast, distributed, and extremely effective in making latency so low, all applications feel very natural. That's pretty much it. I'm long on time, but any questions you have, I'm happy to help out later. And well, thanks, James, for giving me the opportunity because it's a very good and fun experience. And next version is going to be even more interesting. Thank you so much.
Well done, Luca, for pulling it in like that. Now, we've slightly chewed into the break, and so what I'm going to encourage you to do, if you want to talk to James or Andrew or Luca, is to find them individually. We're back here around 11:15 when Saul is going to be talking to us about React Native, so something to look forward to there. But in the meantime, let's give all three of them, Andrew, James, and Luca, another big ComCon thank you.